Hello, welcome back to SAS From Scratch. Today we're looking at Chapter 11 in your SAS Prep Guide, which is Episode 11, as these correspond, as you should know by now. We're going to be looking at do-loops today, iterative loops. We're also going to look at iterative loops that have conditionals attached to them. Before we get to that, however, there's something that I missed. I think it was in Episode 9, thereabouts. And that is the rename statement. So we've looked at quite a few extra little statements and data options such as drop and keep. We've learned how to set lengths, all that kind of, all of those, but we do need to know how to rename variables. Because your other option is going to be to create a new variable from the old one and drop the old one, which is just way too much of a schlep to do. So to give you an idea of what I'm talking about, if we read in the fish data set from sashelp.fish, our old friend, the fish data set. So let's say I want to rename these from length 1 with a number to length 1 the word. Now I could go and do something like this, and then I could say, well, go and drop length 1, and that'll work. If we run that, we'll get what we need. But a much better way of doing it, and I should actually move myself there. Now you can see. So it does work, you can do it this way, but it's extremely overly complicated. The better way of doing it would simply be to say rename length 1 to length underscore 1. And if we do that, we'll see that we have length underscore 1 in here. If we wanted to do it for multiple variables, we could. We would simply say separate by a space, put in the new variable that we want to rename, and we can put as many of them in here as we want to. As always, what you can do is, because SAS will treat everything as a one line until it actually reaches a semicolon, you can neaten these up a little with a bit of indentation and some spacing and whatever it might be. So this will give you the result you're looking for in terms of just renaming those from the number to the word. And just like we saw with the drop, keep, and rename statements, in the same way that you can put a drop statement in here and a keep statement in here for variables you explicitly want to drop or variables you explicitly want to keep and then drop everything else. We can also use it as a data set option. So just how we could say, for example, here drop var1, var2, or we could say keep var1 and var2. We can also rename. The only catch that you need to keep in mind here is when you're renaming, there has to be an extra set of brackets here, parentheses. So you can do exactly the same thing that you did here. I'll just drag and drop those in, but they have to be in between the parentheses. One other thing to bear in mind, and now off the top of my head I can't remember for a fact. So as SAS is going to read these in, it's going to rename them immediately. So in your code, you would have to refer to length underscore 1 in here in the data step, and not length 1, because length 1 will no longer exist. The other thing to keep in mind, I think if you do it as a rename statement and not as a rename option, I believe you still refer to the original name if you want to do something. So let's go and test that quickly. So for this one, we'll have to do let's say double length equals length 1 times 2, that should fail, or it should at least give us a missing, because that doesn't exist. So double length is missing and length 1 is missing, so SAS is creating that variable, but it doesn't exist, so it's missing. So in this case, we know we have to use length underscore 1 if we want to double the length. There we go. However, if we take this rename statement out of here and we say, I'm only going to do the one variable because I think it's easier to keep track of. If we rename this, I believe we'll have the same, we'll just have the opposite issue. So double underscore length is missing, and what's happening there is it's looking for length 1. And it's also giving us another warning, because what we're doing is, because SAS is looking for this, it creates it, and then we also go and rename something again to the same name that the PDV has already been looking for. So in this case, we would need to refer to length 1, and this will work. So there's double the length. So that's just one thing to keep in mind, and note as well that we're referring to length 1 with the number 1, but length underscore 1 is what is actually going out towards our output data set at the end of the day. Okay, that's the rename statement. The only other thing to keep in mind is when you're renaming something in SAS, it is always old variable equals new variable. Whereas, for example, if you were, let me bring this code back. So if we did something like this, it would be old var equals new var. So these are the new names. And if you were doing this in R, you would, for example, have out data set comes from the input data set, and you would select, I believe it's new var equals old var. So the syntax is just reversed between what you'd be doing in R and dplyr and what you'd be doing in SAS. But it's as simple as that. You do need to know this obviously for the SAS base exam. In the same way that you have to know drop and you have to know keep and length and all of those statements, you have to know the rename statement. Let me move myself back up here where I belong. There we go. And I did mention that you will need an extra pair of brackets if you need it as a dataset option. Other than that, it's pretty straightforward. So let's get to the meat and potatoes of today's episode, which is the do keyword. So we saw in episode 9, for example, if we wanted to change from a simple if-then statement, which executes a single line of code, to an if-then statement that can execute multiple lines of code if the conditional, depending on how the conditional is evaluated, we would combine that with a do and an end block. So just to jog your memory a bit, if we had something like this, these are just imaginary data sets. If we said if some conditional, then do something, else do something, these would be single lines of code or single statements that we would execute. And so to get multiple statements, we would combine them with a do block and an end block, or a do end block. And then in between here, we could have multiple lines to be executed. We can do the same for the else statement or the else if statement. So we could say else do end, and in between here, we could have multiple lines of code, each doing, a particular step. So that was one example of the do block, and something that we use the do block for. The other thing that we can use the do keyword for is for iterative loops. So if you're familiar with a for loop or a what else? There's a while loop, do while, do until, all that kind of stuff. That's the other thing that the do keyword can be used for. The do keyword, just like how we saw with the if statement, it's always ended with an end semicolon statement. So those two go together. So some simple iterative do loops that we can look at is we can loop over a range of integers. So by default, if you say do I 1 to 10, it'll be by 1. So it'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can change that by value. So if you wanted to count down, for example, 10 to 1 by -1, that would go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, subtracting 1 every time. We can extend this iterator to be done by a floating point value. So we can do 1 to 10 by 0.5, so that's 1, 1.5, 2, 2.5, etc. until you get to 10. The other thing that's really useful is that we can loop over discrete, arbitrary lists of numbers, strings, or variables. So if you wanted to loop only over prime numbers, you can just put in a few prime numbers there, like I've done in the example here, where I've said primes equals 2, 3, 5, 7, 11, and SAS will loop over this value 2, 3, 5, 7, and 11, and it'll be placed into this primes variable. We can loop over names. So if we do Abe, Bob, and Charlie, this names variable will be Abe, and then Bob, and then Charlie as the loop iterates. And we can do the same for variables. So if we refer to variable in our code, it will be first length, then width, and then height, the actual variables, as SAS loops over these variables that we've specified. And again, remember that this is happening in a row, not in a column. So if we've got length 1, length 2, length 3, then basically what SAS is going to do is something to length 1, something to length 2, and something to length 3. And so if we want to see an example of that, for example, let's go back to our fish data set. Let's just run that. So here we've got our fish data set, as always, length 1, length 2, length 3. And if we do something like do length var equals length 1, length 2, length 3, end, and just notice here that we do split it by commas. I believe that's the syntax. Yes. We can do something like, let's say we want to double each of these lengths. So let's just keep track of what we've got in here. We've got 23, 25, and 30. So we expect to see 46, 50, and 60. So all around the 50, 60 mark, roughly, once we're done. So what we can do is our length variable will in turn refer to length 1, then length 2, then length 3, all in the same row. So if we say length var equals length var times 2, that will go and double each of the values for length 1, length 2, and length 3 in turn. And if we run that, okay, so that's not exactly what we want, because we keep replacing that value. So you would rather be doing this with an array. But at the end of the day, what is actually happening here, so we can put an output here just so you can tell that it does actually loop over that. So each of these rows have now basically been triplicated, so there's 242, 242, 242, 290, 290, 290, and so length 1 is being doubled, and I need to move myself over again. So length 1 is being doubled, and that's 46.4. 23.2 becomes 46.4. 25.4 is then doubled, that becomes 50.8. Length 3 is doubled, that becomes 60. But this is a way of just demonstrating how you would refer to a variable in a do loop. The other way that you would normally do it, just to show you that it is possible, so you would do something like length var is length 1, length 2, length 3, and SAS actually has cool ways of referring to this. So if you say length 1 and then a dash and length 3, SAS will fill in automatically that there should be a length 2 in there. We can then say do over length var, and that should work, I believe, unless I've got the syntax wrong somewhere. No, I don't. So now we again have one record per fish instead of having triplicated it. This was 23.2, it's now 46.4, 50.8, and 60. So that's how you would do it otherwise. But for the purposes of the do loop, just be aware that we can refer to a variable when we do the iterator as well. Not going to get too hung up about that. As long as the understanding is there from your side, then we're good. Okay, I need to go back up here. I really should find a different spot for my face. And do loops can be nested. So in the same way that we saw we can nest if statements, we can nest do loops. That's pretty straightforward. Honestly, this isn't rocket science. If you're coming from a programming background where you've used for loops and if statements and things before, you just have to get used to the SAS syntax basically. Quick note on the iterator variable, because this is quite important. The iterator is always incremented at the end of the loop before it checks whether it's still in range. This means that your iterator is always going to be outside of the provided range by 1 in the output. So if we do something like do I equals 1 to 10, and we say output in here. Now we're not going to see it here, and I'll explain why, but just so you know what is happening, I'm also going to point to this data step iteration variable. So this n variable is how many times has the data step iterated. And so what we can see here is that I would love to just move this in a bit. Wonderful. So what we can see here is I runs from 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10. The data step is only ever iterated once. That makes sense because we're not reading in a lot of records, so it's not stepping through each input record as it's going. There's a single statement. It enters the data step once, n equals 1. It does 10 loops while n is still equal to 1, and then it outputs each one of those. So that makes perfect sense. What does happen, and you're not seeing it here, is that when we get to I equal to 10 and we output it, as soon as SAS gets here to the bottom of the do loop, it increments I to 11. It goes back up, it checks and sees that 11 is not in range, and then it hands control back to the outside of the loop. And a good way of seeing that is if we leave out the explicit output statement here, which means that SAS hands back to the implicit output statement. And I can't remember in which episode I covered this, but it was in one of the previous episodes, I think around 4, 5, or 6. So if this If what I'm saying now between implicit and explicit output statements does not make sense, please go back and watch that, because it's a very, very important part of understanding how SAS works. So if we leave it up to the implicit output statement again, we should see here that I equals 11. And the reason why we're only getting a single record in our end step is because we only have that single output statement. So if we don't put an output statement inside of the do loop, that output isn't executed multiple times. So the PDV keeps changing. The PDV keeps evolving. We keep changing the value of I that's inside the PDV, but we don't see that change because we're not outputting every single state of the PDV. Only at the end, when the loop is completely finished and I equals 11, does the implicit output take that final state of the PDV and pop it into the output dataset. Now, something that's very important that we've talked about before is that when you go and write the SAS base exam, the exam is very much focused towards testing your knowledge of the state of the PDV. You know, questions like, for example, if I give you this bit of code and an error or something halts the execution here, what does the PDV look like? If I give you this do loop with this range, what is the state of the PDV at the end? What is the iterator going to look like? It's always going to be outside of the provided range by 1. If you use a different increment by 0.5, for example, it'll be off by that. But your default increment is by 1, so your iterator is going to be outside of the range by 1. Please make sure that that makes sense, that you understand this, because it is super important. It's definitely something that can come up in the exam. Okay, let's go to our first exercise. And we've talked about do loops. We've talked about everything we need at this stage to write this little compound interest calculator. So we're going to assume a very simple compound interest calculator that only calculates interest at the end of every year. So it does not calculate it daily. Your bank, for example, would calculate the interest on a daily basis in real life. This bank of ours, this fictitious bank, calculates it once a year and then pays out the amount. So we are assuming a few things here. An initial investment amount of $1,000, a 6% annual rate, because interest rates are through the roof. Unfortunately, a lot of us don't see this on our savings. We do see it on, for example, mortgages. So the bank likes to take 6%, doesn't always want to give us 6%. And we're assuming a 10-year investment period. We're going to output the change in the investment amount at the end of each year. You already know what that means. That means we're not going to rely on that implicit output statement. We're going to put an explicit output statement inside of the do loop. Okay, let's get started with that. We can call this, we can take out the fish data set for one. Let's call our data step interest. We're going to set a couple of initial assumptions. Our amount is $1,000. In this case, we'll just put 1,000 in. We know that our interest rate, excuse me. We know that our annual interest rate is 6%, which is 0.06. And we know that our years of investment is 10 years. So the way we can do this is by a simple do loop. We can say, for example, that year, our iterator will call year. We could have called it I. We could have called it anything else, but this makes sense to me. So from year 1 to years invested, in this case that's 10. So notice that we're pointing to, sorry, not years invested, we just called it years. From year 1 to years, which is there. So we're, instead of, hard coding to 10, we're pointing to something up here, and we can always go and change that to 20 and 30, and we'll see how that changes our investment. But notice how in this iteration range, we're referring to a variable. Because we're opening a do, we have to match that with an end statement, and then we can go to work inside of here and decide how we want to approach it. So the way I would like to do it is to say, let's calculate our interest value first, which is amount times annual rate. And then we can say, okay, well, our amount now increases by the interest at the end of every year. And we put an output statement in because we want to see year 1, year 2, year 3, year 4. If we don't put this output statement in, it's still going to run from year 1 to year 10. It's only going to show us the very last state of the PDV, so the very final amount. And this year value will show 11 instead of 10 because it is always incremented before it is checked again. And well, we can take it out and we can see it in action. But for now, let's just focus on getting the interest calculated. Okay, so at the end of the first year, after 1 year of investment, 6% on 1,000 is $60. Makes sense. You can see how our interest is compounded each year from 60, 63, 67, 71, etc. And after 10 years of investment, we are at $1,790. If we take this out, so please keep this number in mind, 1790.84. We're going to see it if we take out this output statement. I'm just going to comment it out, but we will notice that year is equal to 11. Again, that's expected. It's off by 1. The true range was from 1 to 10. Our investment amount here is still 1790.84. The only difference now is that we're keeping the last state of that PDV record before it got output instead of looking at all the intermediate steps as well. So hopefully this makes sense. This is a very simple interest calculator. Very simple, extremely simple. And an extra credits item that I've put in here for the question is to expand this calculator to compound the interest monthly. So we know there's 12 months in a year, and we can do this with a nested do loop. So if we say year equals 1 to years, that's still fine. But now we're going to expand it to say within each year, run from month 1 to month 12. And I'm going to pop another end statement there. And I'm going to indent these. So you can see nicely, and please, you need to focus on your indentation so that it's readable. Something that we don't want to see is this. Please don't do this. You're making your life difficult. You're making the life of everybody you work with difficult because this is unreadable. We want something where we can clearly see where different bits of code are executed. So we know that this is going to run from year 1 to year 10. Within year 1, it's going to go month 1 to 12. For year 2, it's going to go month 1 to 12. And we're going to get all of these different months for each year output as well. Now, the only thing that we need to adjust here is the amount of interest we earn is not going to be at the annual rate, but it'll be at the annual rate divided by 12 because we're not getting 6% a month, we're getting 6% a year. So 6% divided by 12 gives us the amount that we'll actually end up getting each month. And if we run this, we'll see now that we have, let me move myself over. We'll see now that we have the annual rate is still the same, the number of years that we're setting to is still the same. Current year 1, current month. Let's close that up a bit. So at the end of the first month, we have $5 of interest. At the end of the second month, we get $5.025 more of interest, and that keeps adding up. So 1005, 1010, and at the end of the so there's one more thing to keep in mind here. SAS will only display 100 rows at a time. We've got 10 years times 12 months, so we've got 120 rows. So on the next page, we'll see our final amount, which is year 10, month 12, and we have a total final amount of 1819. So the more often you compound interest, the more you get. Recall that if we only compounded it annually, we got 1790. Now that we're compounding it monthly over the same period of time, we get 1819. Okay, that's the first exercise done. So we've done a few things here. We've got a nested do loop, we've got a simple interest calculator, and we've got something that outputs it step by step. And again, we can take this out if we're only interested in the very final number. So here's a question for you. If I do take out this output statement and we're left with only that one record, what is the value of year going to show and what is the value of month going to show? So think about that. In the meantime, let me take this out and I'll rerun it. So we know that year runs from 1 to 10, month runs from 1 to 12, and we're using the default iteration increment of 1. And so year is off by 1, it shows 11. Month is off by 1, it shows 13 instead of 12, but that does not change how many times the data step actually iterated. In actuality, in reality, the data step iterated from 1 to 10 for years and 1 to 12 for the months. Okay, that's exercise 11.1 done. Let me move myself back. I really need to find a different spot for my face. Let's move on to the next exercise. This one has quite a few exercises in it today. And so the next one is, again, using nested do loops and the put log statement that we learned about in episode 5. We're going to write a simple multiplication table calculator that just gives us all the products between all of the integers 1 to 10. And so we want to have a kind of, not quite a lookup, but close to a lookup, that simply says, okay, 2 times 3 is 6, 4 times 5 is 20, etc., etc. And it's pretty simple after the interest rate calculator to do this. So we can just say, let's make a multiplication data step, and just note in all of these that we're not using a set statement. We don't have that read command from somewhere else. We're just putting stuff into the PDV, we're manipulating stuff, and we're outputting it at the end of the day. And so that's perfectly fine and possible to do that with SAS. You don't always have to read in from an existing data set. So for multiplication, again, that's fairly straightforward. We can simply do something like I is 1 to 10, close that off. We know we're going to have to nest it to get that multiplication table. So let's do I and j. And we can simply then say, okay, well, the product we're referring to is I times j, because we won't be able to do that in the put log statement. So the put log statement wants to refer to specific variables that exist, like I, and then j, and then product. It does not want to have to do a calculation within the put log statement itself. So if we say put log I times, and again, if this doesn't make sense to you, episode 5 covers put log and the syntax for the put log statement. So you're more than welcome to go and view that. If you like, you can stop the video here and you can catch up on that topic first. So if we do something like this, we're just going to get whatever the value is of I, whatever the value is of j, and then whatever their product is in the log. So let's run that and we'll see. And again, so here what we've got I11, J11. We can see the product is actually 10 by 10. So we know that's just the very last record that was executed in the PDV. And now if we look at our log, we can see there's our 1 times multiplication table. There's our 2 times multiplication table. There's our 3 times multiplication table, etc. Now, if you come from a computer science background, or you've done, for example, a course on programming and basics of algorithms, you'll notice that 4 by 5 and 5 by 4, we're doing the same work twice. We've got more steps in here than we need. And so the little trick you can do is to have this iterator or this loop only go up to wherever the previous iterator is. And that'll get rid of a lot of that redundant processing that we've got in here, a lot of that repetition. And so if we look at our situation now, we've got 1 times 1. Notice we haven't got 1 times 2. We haven't got 1 times 3, but we do have 2 times 1, we do have 3 times 1, we do have 4 times 1. So that data is still there, it's still being calculated. The only thing we're doing is we're not doing it twice. So we've eliminated that redundancy in the code. So that's a very simple multiplication table calculator that we're just putting into the log. It's really just to demonstrate nested do loops. And to be honest, when I was doing the exercises while I was working it out for these slides, I kind of did this one first, and then I said, okay, well, for exercise 11.1, the previous one, let me add an extra credits here that also uses a nested do loop. So I think this one is perhaps not the best example. It's a nice simple example to work through. But I think exercise 11.1 with the nested do loop is much more a real world application for these do loops. Okay, let's move on. The other thing that we can look at is conditional do loops. This is again very important for the base exam as well. As I've said before, if I've got something in these slides, it's important for the base exam, and then go and look at your prep guide as well. This is not exhaustive, but if it's in here, it means you can expect to see it in the exam. An important difference that we need to just keep in mind. So we've got do until a certain expression is satisfied. So SAS is going to keep running until that expression evaluates to true. And then we've got a do while, and that means SAS is going to keep running while the expression is true. As soon as it goes false, then SAS stops the execution. An important difference to note, an important difference to note between do until and do while is that the do while expression is evaluated at the top of the loop. So if the expression is false to start with, it is never executed. The do until statement will run, I believe, at least once, and then it will determine whether it is false or whether it needs to stop execution. So this is pretty much, if you take out the until expression and while expression bits in the syntax, it works exactly the same as the other do loops that we've been looking at. So previously we've been looping over a range with an iterator. Now we're just going to keep looping until a certain expression becomes true or not. One thing to watch out for here is that you don't want to go into an infinite loop. You don't want to get stuck in something that will evaluate into infinity forever. And a way you can do that is you can, I think within the prep guide, they kind of give you an example of that where I think they add like a counter or something, and they say, look, okay, if you've reached a certain number of iterations, then just exit this expression. We expect that within 100 iterations it should be solvable. If after 100 we're still in here, just leave the do loop. And that's something that you can do with the leave keyword as well. So you can say if iteration 1000, then leave semicolon, and that's how you get out of your do loop as well. For now, let's just be aware of the do until and the do while conditional loops, because that's what's actually important for the exam. Our last exercise for the day is going to be another interest rate calculator. We can use a lot of the stuff we've done before. The only thing that we're doing here is, and we're going to stick with just the annual calculator, to not make it too complex. But we're going to estimate roughly how many years of investment it's going to take us to turn this $1,000 with this interest rate over. No, we're not going to. Actually, this is wrong. So we don't know that it's going to be a 10-year investment period. We know that we have $1,000. We know it's a 6% annual rate. And what we're asking is, with the 6% annual rate compounded annually, how long is it going to take us roughly to double $1,000 to $2,000? So this bit here, 10-year investment period, yet another error in the slides. Just scratch it out and pretend it's not there. So going back to SAS Studio, let's do, I'm going to call this one interest 2. And I'll make an interest 3 as well, and I'll show you the reason why in a little bit of time. So we know that our amount is 1,000. We know that our annual rate is going to be 0.06. And what do we want to do? We are going to say do until our amount is greater than or equal to 2,000. Why don't we just do this? Because if the amount does not at some point become exactly 2,000, we've got ourselves an infinite loop. So if it's less than 2,000, it's going to keep going. If it goes over 2,000, then it's also not equal to 2,000, and it's going to keep going. So we need to say, okay, as soon as you go equal to or over 2,000, stop this loop, and then we'll see where we've got to in terms of years invested. So what we're going to do here is we're going to make an accumulator variable that specifically says years invested, and we're just going to keep adding onto it every time every time the do loop cycles, basically. The rest of our stuff stays exactly the same. The amount of interest we earn is equal to the amount of money that we've got in there times the annual rate. And our new amount is basically the old amount plus the amount of interest that we've earned. And just to give you an example, we can say, for example, if years invested is greater than 100, then leave. And this is just going to be our fail-safe, basically. That if we go over 2,000, so if we do something like this and we go into that infinite loop, then this counter, after we're there for 100 years, we don't think it's going to take 100 years to double our money. It'll simply leave. So that's not going to execute now. But that's just an example of what you would do to prevent the infinite loop if you expect that it might happen. Okay, so years invested is 12. I just want to put in an output statement because I like being able to just see the difference while we're running. So we can see here that at the end of 11 years we have 1,898, and then at the end of year 12, after 12 years of investing, we have $2,012 in our investment. So we've effectively doubled our money. And so we know that it would take us roughly 12 years to do so if we have interest rate that's compounded annually. You could have also solved this with a do while, and the way you would do that, and I'm just going to copy and paste this whole block. These two blocks are exactly the same. I'm going to call this one interest 3, and we're simply going to say while our amount is less than 2,000, keep doing this. So just note here, we said do until the amount becomes more than 2,000, then you stop. Here we say keep going while the amount we have is less than 2,000. So these are two different ways of accomplishing the same thing. And if we run this one, we're going to get 12 years again. We're going to get exactly the same number of, the same amount of interest and investment value, but we've just solved it in two different ways. The one's with a do until, the other one is with a do while. And you can always go and, if you want, for your own practice, for inventing another exercise and doing some homework, you can try and combine that with the monthly compounded nested do loop that we did as well. One other thing you can take into account is you can, for example, so let's say every year you plan to put in a bit of extra money as well, and I'm now going back to our initial example. You might do something to say, well, amount plus 100 or something, so that every year, at the start of every year, you also put in another 100, or maybe at the end of every year, you put in another 100, and then on that, you earn more compounding interest as well. So if you're familiar with a little bit of investing and compound interest, you can play around with this, and you can, I don't know, put in some of your own numbers, your own sums, and then see what the numbers come out to roughly. Don't go and fight with your bank if the numbers don't match exactly. They sometimes, they'll compound it on a daily basis. They sometimes work, I think, on 360 days instead of 365 days, that sort of thing. So banks and the treasury and all of those people, they have their own ways that they do their things with, but this will give you a good idea of what your investments can be worth with compound interest. And just a fun little exercise, and I hope that the do loops are now a bit more clear from when we first started. That's it for do loops. So we have now covered the do blocks when we combine them with if and then, and we've covered iterative do loops when we use them for discrete values, when we use them for integers, floats. We can change the iterator to be a floating point value, to be a negative value if we want to count down. We've covered all of that as well. So that's chapter 11 done. Next time what we're going to look at is the format and informat statements that we use to decorate values and so that's not exactly right. Format statements will decorate your values and will affect how they're printed. Informat statements don't simply decorate the values, they determine how they're read in and how they're going to be stored. We're going to use proc format to create our own formats actually. And we're going to skip ahead a little bit to chapter 14 because the put and input functions are only covered in chapter 14, but because they go hand in hand with format and in format, I'm bringing them forward to episode 12, which corresponds to chapter 12. And what the put and input functions do is they allow you to convert character to numeric and numeric to character, which is very useful. And it's very, to me, it's very different to how you would do that in almost any other language. So if you have, for example, R, you could say as integer or as double. If you wanted to have something become character, you could use the paste function. If you were coming from something like C# or Java, you would parse it as integer or parse it as a string. In SAS, things work a little bit differently, and that might take just a bit of time to wrap your head around. So that's why I'm bringing put and input forward, so that when we're dealing with formats, we also look at put and input, because they're intertwined with the formats basically. However, that's for next time. So thank you very much for watching this episode. I hope it was useful. I hope you enjoyed it. Feel free to leave a like. You can leave a comment if there's anything I can improve on, or if there's anything I missed. And as always, thank you as well for putting up with all my rambling and waffling in between all the actual educational bits. Until next time, cheers. Bye-bye.